Alright, so we're going to do another Kirchhoff's law example here. So we're going to be looking for unknown currents. We need I1 and I3, and there's a missing EMF here. So we're going to start by applying our junction rule, so the sum of the currents equals 0. Now in this case, let's take a look at this. So we have I2 coming towards the left, I3 going up, and I1 also going to the left. So in this case, we're going to have I2 splitting and becoming I3 and I1. So I said I2 equals I3 plus I1. And I know I2 already, so that's going to be the 0.7 amps. But at this point in time, I'm stuck because I don't know I3 or I1. So let's turn to our loop rule. Alright, so there are 3 rules, and you'll notice here that I've written 3 equations out. One of them I never ended up actually using, but let's just review it so that we have an idea of how to do loop rules. Alright, so where did I start? I started here, so I went across the 40 from positive to negative. So since it's positive to negative, it's going to be a negative 40. And then I'm going to go across the 6 ohm resistor, and since I'm going with the current, that's going to be negative, so I'm going to take 6 ohms. And this is in I1 territory, so that's I1. And I come back around, and I go across the EMF. So that's from positive to negative, so that's going to be negative. And then I go across the 4 ohm resistor. And since this is in I3 territory, and I'm going against the current, I'm going to take a positive I3 times 4 ohms, and that sums to 0. For the next rule, I started once again with the EMF. And so since I'm going from positive to negative, that's going to be a negative EMF. And I go across the 4 ohm resistor against the current, so that's going to be positive I3 times 4 ohms. And then I'm going to go across the 7 ohm resistor. So since I'm going against the current, that's going to be positive, so 7 ohms. And this is in I2 territory, that's going to be 0.7 amps. And then I'm going to go across the 14 ohm resistor, still in the I2 territory, which means that it's going to be positive because I'm going against the current, so 0.7 times 14. Now at this point in time, I'm missing I3 and the unknown EMF. At this equation up here, and reason why we just didn't need it when we finished solving the problem, we're missing I3 and the EMF. So we're going to go to our next loop rule. Alright, so we started with the 40 volts again. So we went positive negative, so this would be negative 40. And we're going with the current across the resistor, so this is I1 territory, so negative I1 times 6 ohms. And then we're going to go around the 14. So now since we passed through the junction, we are in I2 territory, and we're going with the current, so this is going to be a negative 14 times 0.7 amps. And then we go across the 7 ohm resistor. And since we're continuing to go around clockwise, that's with the current, and we're still in I2 territory, so it's going to be negative 7 ohms times 0.7 amps. Now as we look this time, our only unknown is I1. So I'm going to follow through with my algebra and find out that the current is a negative 9.12 amps. Now that I know current 1, I can go back to my junction rule and find current 3, so 9.82 amps. And then I can plug into the second loop rule that I wrote and solve for the unknown EMF, so that's 54 volts.